All right, so here is number 5. Someone asked about number 5, and I know you asked about 5b, but let's take a look at how we might come across this. There's a lot going on in this. It's not just one triangle, it's two. So what you might have to do is view this situation with two different triangles. So let's just read it first. It says a crane stands on top of a building as shown. So here's the crane from here to here. Okay. How far is the point on the ground from the base of the building to the nearest tenth of a meter? How far is the point on the ground from the base of the building? So we're looking for the distance from here to here. Okay? That's what we're looking for. And then B is how tall is the crane. So then we're looking for, this is the second part. All right? Okay, so usually in these questions, when they ask you A, they're giving you a hint as to how you would start solving for B. Okay? You girls okay there? Yeah. Little surgery? Okay. Okay. Just out of the corner of my eye, it looked like you were snipping something else there. It was snipping your arm or... Okay. So how far is the point from the ground? Okay. So let's view this as one triangle. And for those of you that have this question, you did this question, just watch to make sure that just cement this in, okay? Make sure I'm doing all this right. So a couple things here. This is 27, height of the building. And because it's a building, I mentioned the other day that the assumption is that the building is perpendicular to the ground. So this is a 90-degree angle. And this angle right here is 32 degrees. Okay? So we have a right angle situation, a right triangle situation. So we have opposite side is given and the adjacent side is unknown. So this one, again, this is basic trigonometry stuff using one of the prime trig ratios. So which prime trig ratio would we use when we have the opposite and the adjacent? So SOHCAHTOA, remember those? So opposite and adjacent, where is that? Opposite and adjacent. Oh, it's over here. So T is which one? Tan. Tangent, right. Okay, so let's set that up. Tangent of 32, that's the angle here. And the opposite side is the 27, so it's equals opposite 27 over adjacent, which I'm just going to call it A. We don't know what it is. We'll just call it the adjacent. Let's make that A. That's what we're trying to solve for. All right, so if you manipulate this equation, multiply both sides by A, divide both sides by tan of 32, you get A equals this, 27 over tan of 32. And 27 divided by tan of 32. Make sure you're in...
Easier to write it like that?
Sorry?
Is it easier just to write it like that instead of...
Is it easier to write it like...
the second way you wrote it there, after you put everything on.
is it easier just to write just this?
Yeah.
Okay, here's the thing. I appreciate the question. I have seen so many kids, so many students get this wrong when they bypass this step. If you don't write that step out, like writing the actual tan, they divide tan 32 divided by 27, or they go 27 times tan 32. When you go directly to this step, there's a good chance that you might get this wrong. Okay? So I would suggest every single time to do it exactly like I'm modeling it for you. And I always do this. If you notice, I never go straight to this, ever, in any class, ever. I don't do it because I don't want to make a mistake. So if I do it, I think you guys should probably do it too, just so you can kind of see, all right, this is a division, right, not a multiplication. I'm dealing with the grade 10s on this too, right? A lot of them just want to go straight here. It's like, Mr. Maxwell, I know this. Okay, but I've seen a third of them get it wrong, right? Oh, why do I have the wrong answer? Well, you multiplied instead of divided. How would you know? Make sure you set up the original tan. It takes you 5 seconds, really, right? And then you can kind of go from here. So just to answer your question, I would strongly suggest write out the tan or the sine or the cosine formula as it stands, then rearrange it from there. Because sometimes the missing value will be on top, sometimes it's on the bottom, sometimes it's the angle. So how do you know, Does that answer your question?
Yeah.
All right. So let's get back to the calculator here then. And 27 divided by tan of 32 is 43.2. Okay. I feel like I did that calculation already while I was talking. So A then equals 43.2. And what are the units? Meters. Okay, so that would be your answer for A. Just a reminder, please don't circle or square or highlight anything other than just the answer. Show me your work kind of in somewhat of a logical order, and then just circle your answer. Because I'm still seeing some of you circling a whole bunch of numbers that you get during the question. And technically, you're communicating to me that there are 5 answers, or 3 answers. Okay, so just be careful with that. Try just to circle one. All right, so B. All right, so we're getting to the actual question here that someone asked earlier. How tall is the crane? All right, so we've got a few things that we know now, right? Including this A now. We know what A is, 43.2. So we have another right triangle here, but I have a bit of a problem, I guess, or I don't know, do I? Maybe I don't. Another right triangle would look like right here. That's supposed to be a straight line there, sorry. But there's another right triangle-ish. I'll make it over here. And so this is 27 plus something else we don't know, and I know that this is an angle here. Okay, well, how tall is the crane? I'm just looking for this part. So let me redraw the diagram here. I'm just wondering if we can just do it fairly simply. I don't know. Maybe we can, maybe we can't. I think the problem is we aren't given, we have to find one more thing. So if this is 43, I've got this is 43.2, and this is 27, but we have this extra piece that we don't know, right? So let's make that x. So we can't just use the primary trig functions. Why? Well, or can we? Tell me. Torn. Yeah, we still have a right triangle here, that's right. So we could find the angle on top. We could, yeah. But I'm looking for this little piece right here. You know, we don't have to use, I mean, I'm just double checking here, but like I said, I don't have the answer in front of me. But I don't think we have to use the sine law or the cosine law or anything here, because I'm just looking for this. So watch this. If this is the opposite side, this whole thing is the opposite side, it's actually 27 plus x. And this is the adjacent side, and this is the angle. I'm given that angle. Then I could actually solve for the opposite side. And whatever that is, I just take 27 away and I get my x part. So this one actually, let's just follow through my thinking there. Okay? Just let me clean up some of this stuff. I'm going to get rid of A here as well. So I don't think you need the cosine law or anything for this. So given this, let's say, what is the trig function I want to use if I'm dealing with opposite side and adjacent side? Opposite side, adjacent, same, tan, right? So let's say tan of, what's this angle here, this big triangle? It's 43 degrees equals, now opposite side is actually 27 plus x. Okay, could you call it just the opposite side and subtract 27 later? Yeah, but let's just call it what it is here, and this isn't too scary. Let's just try and work with this. So 27 plus x over what? 43.2, opposite adjacent, 43.2. Okay, so here's my missing piece right here. So if you multiply both sides by 43.2, this is what it looks like. Okay, because it would cancel off over here, right? And we'd left with it over here. Okay, so notice that this is just a number value, okay? It's just a number, so I can do that on my calculator. 43.2 times tan 43 is 40.28. Now to solve for x, what do I do to solve for x now? Yeah, subtract 27 from both sides. So when I subtract 27 from both sides, I get 13.28. Or to the nearest tenth of a meter, 13.3 meters. Okay. Does that line up with your answer, those of you that did that? Yeah? Okay. Did anybody do it any different way? Yeah? How'd you do it?
I found on the smaller triangle inside.
Yeah.
I found all three angles.
Okay.
And then, since I had the two sides of it already, I found like that. This is hard to explain.
Yeah, it's hard to explain. So you found this angle. Obviously, it's the difference between 42
Yeah.
and 33, right? So it's
Yeah,
11
and then
degrees.
Since I had the top inner angle.
This one right here? Okay.
No,
Oh, this one right here?
the one underneath it.
Oh, this one right
Yeah.
here. Oh, okay.
Then I could find
So you
one
could,
above it,
okay,
and
so
then
you got
find all
this
three
one.
angles.
And then you got all three angles. Good.
Yeah, and then I could find the side length on the inside line.
Okay, well, if you have side, or if you have angle, you can't, that's right, you can't find this. So then you did which one?
It's hard to explain. It's like-
Yeah, no, it's good. You're doing great.
Then since I had two sides of the smaller triangle, so I could find the third side using Pythagorean theorem.
Okay.
And then I used that to find
So,
the last side.
so you found this side,
Yeah,
okay, because you had this one and this one,
yeah.
right? Okay. So then, and how'd you find this one?
I didn't read that one. So
Okay.
I could use sine law instead.
Okay. So once you found this one, then you use sine law.
Yeah.
Okay. All right. I think because it's in this section, I thought that you had to use sine law, cosine law. You didn't have to, but that's the way you would do that. A few more steps, but that's right. You would focus on this as a smaller subtriangle. That's correct, and then solve for this side right here. Okay. There you go. That's how you do that one.